Welcome back to FPGA Forge, where we forge digital hardware one bitstream at a time. I'm Christopher Williams. Today's lesson, we'll forge our very first hardware design using SystemVerilog on the Nexys A7 board. If you're just joining the series, you may want to watch the first tutorial, Opening a Vivado project using Nexys A7 FPGA board, where we created the base RTL project, which we will start with today. Once you've completed that lesson, come back here and we'll begin designing hardware together. Now, to start with, we're going to open the base RTL project. Today's project is simple, but it's one of the most important exercises in digital design. Today we're going to implement several logic gates, an AND, an OR, a NOT, NAND, a NOR, an XOR, and an XNOR gate. We're going to use the two slide switches on the Nexys A7 as inputs, and each gate will have its own LED output so that we can exercise the gates and watch in real time and observe every output simultaneously. Step 1 will be saving this project under a new name by going to Project, Save As, and we're going to choose a new name. This one will be called Logic Gates. And that's going to create its own project subdirectory. And all we have to do is click OK, and that should save it. Confirm up here, logic gates. So the next thing we're going to do is we're going to edit the constraints. For this project, we're going to need the switches and the LEDs. So I'm going to uncomment the switches. I'm just going to uncomment all of them, even though I'm only going to use two. Uncomment the LEDs. And we want to make sure we save the constraints file. The next step is to create our top level module. We'll do that by clicking on Design Sources, right click, click on Add Sources. We're going to select Add or Create Design Sources. Click on Next. We're going to create files. If we had one already created, we could just add, but we want to create the file. We're going to choose SystemVerilog here, and then we're going to go ahead and name that. We're going to name it Logic Gate Top. Click OK. We're going to click on Finish. We're going to go ahead and click OK here. Click Yes, and that should populate a new top level module, top gate top, or Logic Gate Top. If we double click on that, it'll open it up here in the editor. And we can see that there's a module Logic Gate Top. So the first thing we're going to do is we're going to define some inputs and outputs for our module. These are going to be logic level. We're going to use two switches for this example, so we can define those as, which is like an array. We can put in a comment here. So that we know what this is later. And then we're going to put a comment in here for the LEDs, which will be our output, which for those we're going to use, probably going to use about 6. So that would be, I know we're going to use 7. Yes, 7, starting with 0. So we should, oh, I've got that as a switch right there. This should be an LED. Also, you might want to verify by opening up your constraint file, and see how this is a capital SW and this is a capital LED. This is case sensitive, so if you made that a lowercase SW, it would not work. So out here, we're going to define some aliases, which will just be a single bit, and we're going to assign them the value of a switch each. So that we don't have to keep typing that in. So here we'll create our logic gates. Our output will be led 0. This first one's going to be an AND gate, so we'll use the AND symbol. Just put a comment in here. So we know later. We'll do an OR gate here. This will be a NOT gate. Here we'll do a NAND gate. So here we'll do a NOR gate. Here we'll do an XOR gate. And here we'll do the XNOR gate. And then we need to make sure that we have an in module, and we need to save it. Notice they have a time scale here, 1 nanosecond to 1 picosecond. You also will need that. So now we're ready to run the synthesis. See up here, it's running. This takes a while sometimes. So the synthesis is completed. We get this little message asking us if we want to run implementation. I'm going to click OK. You can see it's actually running the implementation right now. The implementation is successfully completed. We want to generate the bit stream next. Click OK there. The bit stream is completed. We want to open the hardware manager. And we want to open the target. You want to make sure your board's plugged in and turned on right now. We use Auto Connect. And we should see our board right here. There it is. So we'll select Program Device, choose the device, and hit Program. And we should have a programmed FPGA. So it's time to test our hardware. Here's our inputs. This is A and this is B. We'll test the first gate first, which is this first LED. So if we push the first one on, this is an AND gate, so it should stay off. If we push the second input on, it should stay off. If we push both inputs on, you can see that the first LED comes on. And that verifies the truth table of an AND gate. The second gate is an OR gate. First one on, second one on, both on. We can confirm the second gate is working. The third gate is a NOT gate, so it'll be the opposite of this input here. So you can see that when I move the input A, it changes. So the fourth gate is an AND gate. It should be the opposite behavior of an AND gate. So if both inputs are on, it turns off. If either input is off, it turns on. If both are off, it also turns on. So the next gate is a NOR gate, which would be the opposite of an OR. So if either one is on, it should turn off, or both, it should turn off, and we can confirm that behavior. So the next gate is an XOR gate, which should be off if the inputs, let's see which one is that. Is 1, 2, 3, 4, 5, 6. Okay, so yes, the 6th LED, which is this one right here, it should be off if both inputs are the same. If the inputs are different, it should come on, and we have confirmation that that behavior is working. So the next gate is a XNOR gate, and I believe it will be the same if the inputs are the same. So if both inputs are on, it's on. Both inputs are off, it's on. If the inputs are different, however, it will turn off, and we have confirmation that is what's happening. So today we learned how to create a Vivado project from an existing design, configure the FPGA using the constraints file, create our first SystemVerilog top-level module, and implement 7 different logic gates and test them. We ran the synthesis, the implementation, we generated a bit stream, we programmed the FPGA, and then we verified the design on the actual hardware. If you found this tutorial helpful, please give a thumbs up and like and subscribe. Thanks for tuning in. I'm Christopher Williams, and until next time.